The crescent moon's increasing brightness tends to draw our attention as the full moon draws near. The moon is fully lighted by the sun when it is full because it is on the other side of the planet from the sun. The moon, however, has some secrets up her sleeve on each given day of the month. Here are some odd and unusual facts about the moon that can shock you. From Earth, we can view little more than half of the moon. The majority of reference books will mention that we never view more than half of the moon's total surface because it rotates only once during each revolution about the Earth. However, the truth is that due to its elliptical orbit, we actually get to view more of it, 59%, almost 3/5. We occasionally view just around the edge of each limb of the moon because its rate of revolution is not uniform, but its rate of rotation is. In other words, despite coming together towards the end of the month, the two motions do not completely follow one another. This phenomenon is known as longitude libration. As a result, the moon rocks in the east and west, giving us a greater sense of longitude at either edge than we would otherwise have. From our vantage point, we can never view the remaining 41% of the moon, and if someone lived there, they would never be able to see Earth. To match the brightness of the sun, there would need to be millions of moons. The sun is 14 magnitudes brighter than the full moon, which has a magnitude of -26.7. The moon's brightness is 398,110 times that of the sun, for a ratio of 398,110 to 1. Therefore, to match the brightness of the sun, you would need that many full moons. But none of this matters since the sky is too small to accommodate that many full moons. Over 41,200 square degrees of sky are present due to the sky's 360-degree circumference, which includes the portion below the horizon that we cannot see. The moon has an area of only 0.2 square degrees and is only half a degree across. So even if 206,264 full moons were to cover the entire sky, including the half that is directly below us, they would still fall 191,836 shy of the sun's brightness. A full moon's brightness is double that of the first or last quarter moon. The brightness of the moon's surface would be uniform if it were like a completely smooth billiard ball. It would in fact look to be half as bright in that scenario. But the geography of the moon is incredibly unforgiving. The lunar terrain appears to be covered in many shadows produced by mountains, rocks, and even microscopic grains of lunar dust, especially near and along the day/night line, also known as the terminator. The moon's surface is also speckled with black areas. The result is that the moon is just 1/11th as brilliant at first quarter as it is at full. Because some moon features at that phase reflect sunlight more than others, the moon is really a little brighter at first quarter than at last quarter. A moon that is 95% lit looks to be half as brilliant as a full moon. Unbelievably, 2.4 days before and after a full moon, the moon is just half as brilliant as a full moon. The brightness of the moon is about 0.7 magnitudes less than at full phase, making it appear half as bright, even though about 95% of the moon is lighted at this moment, and to most casual viewers, it may still appear to be a full moon. The Earth experiences phases as seen from the moon. They do not, however, correspond to the moon phases that we can observe from Earth. We see a full Earth when the moon is new, a last quarter Earth when the moon is first quarter, a crescent Earth when the moon is gibbous, and a full Earth when the moon is in its new phase. The Earth would always be in the same position in the sky from any location on the moon, with the exception of the far side, where you cannot see the Earth. Our Earth seems approximately 4 times as large and shines anywhere between 45 and 100 times brighter than a full moon when viewed from the moon than it does when viewed from Earth. Therefore, when a full, or nearly full, Earth appears in the lunar sky, it casts a bluish-gray glow on the nearby lunar surface. When the moon appears to us as a crescent, we can see that glow from here on Earth. Sunlight only illuminates a small portion of the moon, and the remainder of its shape is only weakly visible due to Earthlight. The first person to understand what that weird glow on the moon was Leonardo da Vinci. When viewed from the moon, eclipses seem inverted. Not just phases can be observed backwards from the moon. For us, a lunar eclipse is the sun being blocked out by the moon. The Earth's disk appears to be blocking the sun in this instance. If it totally obscures the sun, our atmosphere is backlit by the sun, which leaves a thin ring of light encircling the dark disk of the Earth. Given that it is made up of the combined light from all the sunrises and sunsets happening at that precise instant, the ring appears to have a ruddy color. It is for this reason that the moon appears ruddy or coppery during a total lunar eclipse. An observer on the moon can watch over the course of 2 or 3 hours as a small, distinct patch of darkness gently moves across the surface of the Earth during a total eclipse of the sun here on Earth. The dark shadow cast by the moon, known as the umbra, falls on Earth, but unlike during a lunar eclipse, when the moon can be fully swallowed by the Earth's shadow, the moon's shadow is only a few hundred miles broad when it comes in contact with the surface. The naming of craters on the moon is subject to restrictions. Asteroids and comets that struck the moon caused the craters to form. There are estimated to be some 300,000 craters on the moon's near side alone that are larger than 1 kilometer, 0.6 miles. These bear the names of academics, researchers, creatives, and explorers. For instance, Nicolaus Copernicus, a Polish astronomer who discovered that the planets revolve around the sun in the 1500s, is honored by the name Copernicus crater. The Greek mathematician Archimedes, who made numerous mathematical breakthroughs in the 3rd century BC, is honored by having his crater named after him. In 1645, a Belgian engineer named the moon's main features after kings and other notable individuals, starting the tradition of giving human names to lunar formations. He gave Philip IV of Spain's name as the name of the greatest lunar plain on his map of the moon, which is today known as Oceanus Procellarum. However, barely 6 years later, Giovanni Battista Riccioli of Bologna finished his own big lunar map, removing the names given by Van Langren and replacing them with names primarily derived from those of illustrious astronomers. This map became the basis of the system that is still in use today. The names of all lunar formations adopted by the International Astronomical Union were listed in Who's Who on the Moon, a catalog of officially named lunar formations published in 1939 by the British Astronomical Association. The IAU still chooses names for all celestial objects, as well as for craters on our moon. Each specific celestial feature's nomenclature is coordinated by the IAU according to a predetermined concept. Nowadays, crater names often fall into one of 2 categories. Moon craters are frequently named after notable living scientists, scholars, explorers, and artists who made significant contributions to their professions. The surrounding craters of the Apollo crater and the Mare Muscoviense will bear the names of deceased Russian and American astronauts and cosmonauts, respectively. The temperature on the moon spans a wide range. You'll find a lot of misunderstanding if you search the internet for lunar temperature information. Even within a single page, there is minimal uniformity in the temperature scales that are mentioned: Celsius, Fahrenheit, and even Kelvin. We have chosen to use the data that NASA provides on its website. At the lunar equator, the temperature varies from a very low -280 degrees Fahrenheit, -173 degrees Celsius at night to a very high 260 degrees Fahrenheit, 127 degrees Celsius during the day. The temperature is always close to -400 degrees Fahrenheit in some deep craters near the poles of the moon, -240 degrees Celsius. The surface temperature of the moon can drop by around 500 degrees Fahrenheit, 300 degrees Celsius, in less than 90 minutes during a lunar eclipse as it slips into the Earth's shadow. That was for today. Thank you for staying with us. Don't forget to like our video and subscribe to our channel.